This video is about electric fields. After working through this assignment, you should be able to use E equals F over Q to find the strength and direction of electric fields from given forces, describe the relationship between the direction of force on a given charge and the direction of the electric field that causes that force, and determine at a given point the magnitude and direction of the net electric field produced by one or more charges. To get the most out of this video, you should have a solid understanding of vectors, especially adding vectors using components, and unit vectors such as I hat, j hat, and r hat, which denotes the radial direction. You should also know Coulomb's law for the electric force between two charges. You'll recall that the force exerted on Q naught due to Q can be determined using Coulomb's law. This force F arises from an interaction between the charges Q naught and Q, or it's sometimes described as an interaction between Q naught and the electric field produced by the charge Q. The electric field produced by the charge Q is defined as the electric force between Q and Q naught divided by Q naught. Using this definition, replace F with Coulomb's law for the force between Q and Q naught, and cancel Q naught. This is essentially the same as removing Q naught from the picture entirely. When you do this, you find the electric field produced by the point charge Q at a distance r away from the charge. If you put Q naught back in that spot, then it'll feel a force equal to its charge times the electric field in that location. This is Coulomb's law for the electric field produced by a point charge Q at a distance r away from that charge. The magnitude of the electric field is K, the Coulomb constant, times the charge divided by the distance squared. To find the direction of the electric field, you can use the positive test charge method. Imagine that you place a positive charge at the point where you're measuring the field. The direction of the force on that charge is the direction of the electric field at that location. Consider a point charge of positive 1.9 nanocoulombs. What's the electric field produced by this point charge at a distance of 5.3 millimeters from the charge? First, determine the direction of the electric field using a positive test charge. This charge will feel a force outward, away from Q in the radial direction. So the electric field produced by Q must point away from Q in the radial direction. Then find the magnitude using Coulomb's law for the electric field. The Coulomb constant, K, is 8.99 times 10 to the 9 Newton meters squared per Coulomb squared. Q is 1.9 times 10 to the minus 9 coulombs, and R is 5.3 times 10 to the minus 3 meters. The meters squared cancel, and one of these coulombs squared cancels with this one, to get 6.1 times 10 to the 5 newtons per coulomb in the radial direction. This means anywhere on a circle of radius 5.3 millimeters centered on Q, the electric field will have this magnitude and will point away from Q in the radial direction. At what distance from that 1.9 nanometer Coulomb charge will the electric field have a magnitude of 2.2 times 10 to the 5 newtons per coulomb?